Now, do we remember what the absolute value represents? Absolute value talks about a distance from the origin. So we can also understand absolute value in a complex plane, where I might have some point in complex form, some z equals a plus bi. So we are able to understand that there is a distance from the origin, which we call our absolute value. So let's imagine I have some point, I put it in this first quadrant, and we're able to go ahead and define the distances of a and b, its length and width, to that and develop a triangle. From that triangle, through Pythagorean theorem, this distance, it becomes the square root of a squared plus b squared. So we can think about our points, our complex points, all having a defined distance from the origin, or its absolute value. And we're going to denote that as z with the two bars, the absolute value, equals the absolute value of the particular point. And we can define it in terms of our lengths, a squared plus b squared, and it's the square root of those. So let's get comfortable with that with a couple of examples of how we can understand and come up with the absolute values of complex numbers. So let's take a couple of points that I have to find on the complex plane. Z equals 3 plus 4i. That's over 3 units in the real number part and up 4 units in the imaginary direction. How do we find out what its absolute value is? Which is again asking us how far away from the origin does that point lie in the complex plane. So we can use our formula, our distance formula, which will say it's a squared plus b squared. So I'll take a 3 squared plus a 4 squared and work that down. 3 squared is 9. That's a 9 plus a 16. Square root of 25, which equals 5. So the absolute value of z equals 5 units. All right, let's get an idea of how far away this point in this third quadrant is from the origin, or what its absolute value is. So the absolute value of z, again, follows this square root pattern. So -1 squared plus a -2 squared that goes a 1 plus a 4. It looks like it equals a 5, or root 5 in that particular case. So the absolute value of the second coordinate point in our complex point, or in complex plane, is the square root of 5. All right, are you guys all right with that? I think some of you guys are going, well, wait a minute, Willie. This looks real similar to how we've done it before. And you're absolutely right. The only difference is we're getting used to terminology and working within the complex plane. So that's the only difference that we're seeing right now as we're looking for how to determine distances and absolute values.